Hello everyone, Raghavir back with another video. In this video, we will discuss another technique from the NLP world, which is the technique of topic modeling. What is topic modeling? In my words, topic modeling is the process of extracting major themes from a given corpus of text data. And why do we need it? Because the amount of the written material we encounter each day is simply beyond our processing capacity. Topic models can help to organize and offer insights for us to understand large collections of unstructured data. A brief history about topic modeling. Original technique for topic modeling was developed in 1998 by Raghavan, Tamaki and Vempala. Then came the PLSA, the Probabilistic Latent Semantic Analysis, created by Thomas Hoffman, and most commonly used technique called the LDA, Latent Dirichlet Allocation, was developed in 2002 by Andrew Ng, David Bly and Michael Jordan. Another alternative to LDA is the HLTA, the Hierarchical Latent Tree Analysis, but in this video I am only going to show you how to use LDA technique to find topics in your text data. Alright, so let's get started. First up is dependencies. Here we import the pandas library for data processing, Gensim, which is the main package containing the LDA models and functions for topic modeling. We also import PyLDA-Viz for visualization of LDA model results, NLTK for stop words and lemmatization, and a few other helper libraries. And if you already don't have these libraries on your machine, you can easily install them using pip install. In the next cell, I'm importing my data file, which contains 10 news articles which I have downloaded manually and saved into a pickle file. This dataset contains 5 articles on coronavirus topic and 5 on iPhone related topic. Here you can see the whole data frame with 2 columns, one containing the topic and second containing the news article text. We will fit the LDA model on the text column of this dataset and compare the results returned by our model with the topic column. Before we can feed the dataset into our model, we need to prepare it by cleaning the data first. In this next cell, I am removing stop words, punctuations, and lemmatizing the text and returning the normalized text as a list of words. And then I apply this function to the whole text column of the data frame and store it into a new column called text_clean. This is how the data frame looks like with the new cleaned column. After cleaning, we need to create the dictionary of words from our text corpus. Corpora.dictionary will find out all the unique words in our cleaned text column. To see the number of unique words in your text corpus, you can print the value of dictionary.num_nnz attribute. Using this dictionary, we will convert the clean text in each row into a document term matrix, or also called bag of words, which is nothing but a matrix which stores the occurrence and frequency of each word in the article. As we have 10 articles in total, this matrix will have 10 rows. In the next cell, we instantiate our LDA model from the gensim.models package. In order to fit the LDA model to our text data, we need to pass our document term matrix and number of topics which we believe we have in our text corpus. I will show you how to adjust this number to get the best results. You also need to pass the dictionary that we created above and number of passes the algorithm will take on the whole dataset. So here it will go over our dataset 50 times, which is an arbitrary value I have set it to. You can play around with it to improve your results. However, for most cases 50 is optimal. I am also setting another parameter, minimum probability, which will be used to find which article belongs to which topic identified by the LDA model. This cell takes a long time to execute if you have a large volume of data, and for that I would recommend you use the LDA multi-core module, which I have already imported in the dependencies section of this notebook. By the way, I will upload the notebook and the dataset to my GitHub repo, and you can get the link from the description section below. I make regular videos on topics from data science and share my notebooks on GitHub, So if you want to see more of my content, please do subscribe to my channel. It will help me a lot. Back to our notebook. In the next cell, I am printing the topics identified by the LDA model, which shows the words and their probability of belonging to a particular topic. So in the first row you see, it has identified a topic related to iPhone security. Second one is about lockdown due to coronavirus. And third one is about iPad and apps. As we gave number of topics value as 3 to our model fit function, the model has returned only 3 topics. You can increase or decrease that number and fine-tune your fit by visualizing your results, which I'm going to do in the next cell using the PyLDA-Viz library. This cell also takes a bit of time to execute and generate this complex looking visualization. All we have to do to read this is to check the left-hand side inter-topic distance map, which has these circles representing each topic. If you hover over them, you will see which words belong to that topic and what is their frequency. The most important thing you need to check from this visualization is to ensure that the circles never overlap. I will now increase the number of topics to 10, and you will see that some topics are now overlapping, which is not a good fit, and you must reduce the number of topics to always have non-overlapping circles on the left side of this visualization. So here I am increasing the number to 10 and running these cells again. Let's wait for the visualization to update. As you can see, these two circles are overlapping, and hence this is not a good fit, and you must reduce the number of topics. I'm setting it back to 3 and running the cells again. Now that we are done with the model fit, we can use the probabilities calculated by our model to find which articles in our dataset belong to which topic identified by the model. And we do it by getting the probabilities for each topic from the LDA model object for each article. Here I am printing the probabilities returned by the model for each article and topic. You can see that the article 1 has been assigned a very high probability of 99% for topic 2 and very low for topic 1 and topic 3. In the next cell, I am calculating the threshold which will be used to define our clusters and retrieve the articles for each cluster. I will use this threshold to get the indices of articles in each cluster. As you can see, there is an overlap where one article belongs to 2 clusters. This overlap is possible and is different from the overlap I described earlier with regards to the visualization. Now I am printing articles from the original data frame for each cluster. You can see in cluster 1 there are 3 iPhone articles and 1 coronavirus article. Cluster 2 has all coronavirus articles, whereas cluster 3 has 1 corona and 2 iPhone articles. And with that, we have reached the end of our notebook. You can play around with different number of topic values until you are satisfied with the model fit. Usually for real-world datasets, you should aim for number of topics until you get overlapping circles in the distance map of the model visualization and settle for a number 1 below that. And there you have it, LDA topic modeling, which you can use to extract topics from unstructured data and get an idea of major themes in your dataset. You can even use it on tweets to classify them into a particular topic of interest that you are tracking. I have personally used this in a supply chain risk management project to track real-time natural disasters or political disruptions using tweet data. Alright guys, I hope this video was helpful and this new knowledge will be useful in your projects. I am grateful to you for taking time to watch this video. If you have any feedback, please drop a comment in the comment section below or follow me on Twitter @DataRaga. If you think this video helped you in any way, please do hit the like button and share it with your friends who might be looking for this information. I regularly upload videos on topics from data science and would request you to subscribe to my channel for more such videos. Please remember to hit the bell icon to be notified when I upload my next video. Until then, have a nice day, keep healthy, stay safe, bye bye.